Hello everyone. Sometimes when you want a coffee and while we are waiting for the coffee in coffee shop, we check our emails on our phone, and when the coffee is ready, we stop checking emails and drink the coffee. Would it be great if we also can do this in programming? While some part of the code is waiting for something, maybe network request or IO task, some other part of the code runs at the same time. And as a result, the app does more work in less time. Or said in other terms, the app does not waste time waiting for the network request or IO task to finish, but uses that time to execute another part of the code. In programming, we achieve this with concurrency. So first, let's see a function that does not use concurrency. It gets the URL as parameter and saves the response as a file. We have a list of URLs, and for each URL we execute the function with the URL. And in the end we see how long it took to execute. So we can execute the first example and we can see it takes some time. It took about 6.8 seconds to download 13 images. So a way we can make this faster is by using threading. So there are two ways of achieving concurrency. The first way is while waiting for something to finish, the app executes some other part of the code. And the second way is to execute code in parallel in different CPU cores. So today we are focusing only in the first way of concurrency. And specifically in Python are a few ways of achieving this. The basic idea is that there is an implementation of scheduling for the execution time of each function to give some CPU time to execute. The first and most known is using threading module. Threading allows us to execute a function while we continue executing some other part of the code. So here is an example of threading. We import thread from threading. And creating a thread is as simple as just entering the name of the function, and we can pass arguments as a tuple. Here's an example in which I am downloading only the first image. After creating the thread, we have to start it, and here we can execute any other part of code. If you want to make sure that the function executes until the end, we can join the thread. So we can run this example. Here we are also printing the downloaded image URL to see that the function is running, and as we can see, it downloaded the first image. To download the list of images, we have to create multiple threads. So an example of creating multiple threads and downloading multiple images. Here is the same function as we had before. This is the list of images. And we also create a list of threads to save the threads. We iterate for each image URL, create the thread, start the thread, and we append the created thread to the list of threads. After creating the list of threads, for each thread, if it is still running, we join. By joining, we wait for the execution of the code to finish. This way we make sure that before ending our application, all threads have finished execution. We can try running this function. And as we can see, it took about 1.3 seconds to download 13 images. Where if we compare with our first example, which it took much longer, as you can see. It's 7.3 seconds compared to only 0.8 seconds this time. This also depends on the network connection, but as you can see, it is much faster. Another way to create and manage multiple threads automatically is ThreadPoolExecutor from concurrent.features. ThreadPoolExecutor allows us to create a pool of threads managed by the system, execute the function with an iterable list of inputs and get the values. For example, here we have the list of URLs. So using a context manager we create the executor with ThreadPoolExecutor as executor, and the executor provides us a function called map, which takes as argument the function and one iterable. In this case is download image, and the iterable is the image URLs, which is the list of URLs. The map function from the ThreadPoolExecutor also has a return value which we can return here, and the order of the returned values is in the same order as the input values. So the first URL is going to return first. We can try running this function. As you can see, it took 1.3 seconds almost. So this was an example using ThreadPoolExecutor. Another way to achieve this in Python is using async code. Instead of relying on the system to split the execution time between threads, it has its own event loop which manages the execution, and you can choose when you give execution to another function. We are going to cover async functions in another video in more detail. So that has been it for this video. I hope you learned something. Thank you for watching, and do not forget to like the video if you liked it, and if you want to see more videos like this and support the channel, please subscribe.